Acids and Bases, Part 3, Chemical Equations for Acids and Bases. In this video, you will learn to identify the balanced chemical equations for acids and bases as they are dissolved in water. Recall this general equation for the reaction that occurs when an acid is dissolved in water. HA reacts with H2O to produce H3O plus and A minus. Where HA is the acid, notice the H at the front of the formula. H2O is the water, H3O plus is the hydronium ion, and A minus is the leftover -1 anion that remains after a proton is removed. Let's apply that definition and generic equation to identify the correct equation for what occurs when perchloric acid, HClO4, is dissolved in water. Take a moment to consider these four options. Which of these is the correct, balanced chemical equation showing that perchloric acid does what an acid does in water? I'll give you about 15 seconds. Option B is the correct balanced chemical equation showing that perchloric acid is indeed an acid. Remember that acids will produce hydronium ions in water, and that they do this by removing an H plus from the acid and putting it on the water molecule. Option A is incorrect because it is not a balanced equation, and because chloride ion is the leftover anion when hydrochloric acid, HCl, produces hydronium ion, but not when HClO4 reacts with water, because it will produce ClO4-, called the perchlorate ion, instead. Options C and D are incorrect first and foremost because each one produces OH-, which is the hydroxide ion that bases produce in water. Remember that acids in water will produce the hydronium ion, H3O+, and not the hydroxide ion, OH-. Here we can review the two types of reactions that occur when a base is dissolved in water. For metal hydroxides, BOH dissociates into B plus and OH-, where BOH is the metal hydroxide base, B plus is the metal cation, and OH- is the hydroxide ion that all bases will produce in water. Also shown here is the equation for ammonia in water, which produces hydroxide ions by removing an H plus from H2O to make OH-. The equation is NH3 reacts with H2O to produce NH4 plus and OH-. Let's apply the definition of a base and the generic equation to identify the correct equation for what occurs when calcium hydroxide, Ca(OH2), is dissolved in water. Take a moment to consider these four options. Which of these is the correct, balanced chemical equation showing that calcium hydroxide does what a base does when it's in water? I'll give you about 15 seconds. How'd you do? The correct answer can only be option C, which correctly shows the balanced equation for this ionic compound dissociating into metal cation, Ca2+, in this case, and the hydroxide ion. To balance the equation, a coefficient of 2 is needed for the OH- because there are two hydroxides in the formula for the calcium hydroxide on the left. Options A and B cannot possibly be correct because even though they are balanced equations, they show the formation of hydronium ion, that's the ion for acids, and not the hydroxide ion, the ion that bases produce in water. Option D is not a balanced equation. In fact, there's no way to balance the equation shown in option D because somebody put a water molecule on the left side of the equation. Remember that metal hydroxide bases simply dissociate into water, unlike acids. You cannot balance the equation if you put H2O on the left side of the equation for a metal hydroxide base. How about this one? I won't tell you whether it's an acid or a base, so I'll leave it up to you to look at the formula and decide for yourself. Which of these four equations shows the correct balanced equation for the reaction that occurs when this substance, HC2H3O2, is dissolved in water? I'll give you another 15 seconds to consider. Option A is the only correct possibility. This molecule is actually acetic acid. I know it is an acid because of the hydrogen atom shown at the front of the formula. It is a molecule too. The only covalently bonded base we'll be considering in this course is ammonia, NH3, and this is not ammonia. Because it's an acid, we'll take one proton off the front of the formula. Of course, for acetic acid, there is only one H in the front, but anyway. We'll take one H plus off the front of the molecule and move it to the water molecule. This produces the hydronium ion, H3O plus, and the leftover anion is acetate, C2H3O2 minus. Option B is incorrect because even though it is a balanced equation, it incorrectly removes all the hydrogens, even the ones in the middle of the formula, and not just one from the front of the formula. Option C is incorrect because this molecule is an acid, so it will produce H3O plus and not OH minus. Option D is incorrect primarily because it's not balanced. The H2O molecule is missing from the left side of the equation. Here's a question for you. What are the ions that are present whenever ammonia dissolves in water? You'll need to stop and consider whether ammonia, NH3, is an acid or a base. After that, you'll need to consider how exactly ammonia reacts with water to produce ions. And I'll give you about 15 seconds to consider this one too. Shown here is the balanced chemical equation for how ammonia, NH3, reacts with water, H2O, to produce ions. The ions that are produced are the ammonium ion, NH4+, and the hydroxide ion, OH-. Ammonia is a base. It is a molecule that accepts H+ from H2O to make OH-. Because it makes hydroxide ion, it is a base. To recap, in this video, you learned how to identify the balanced chemical equation for the reaction that occurs when an acid or base is dissolving in water. Thank you for watching.